lateral corticospinal tract originates in preceptor comes down through the pyramidal decussation and crosses, and comes out here, goes up here, and goes up here, and then we got the
Dr. Mo?
cerebrospinal, and we got the just going across here, and yes, Cameron.
Could you please slow down? You go a little fast.
Is there a problem?
Yeah. Just I don't understand what you're talking about right now.
Can I read this? I've gone. Am I talking too fast?
Hey, Dr. Mo, I have something for you. This might slow you down a little bit. It's a bag of tobacco products.
Are you serious?
Yeah.
Steph. Thank you. Well, class is over for today. I'll see you guys next week. Make sure you go over this. Huh. This looks like a rolled up napkin.
For Dr. Mo to light the lighter, we first start in the brain, the direct motor pathway which involves the prefrontal cortex, basal ganglia, globus pallidus, putamen, substantia nigra, via nucleus, and the cerebellum. These parts of the brain will initiate an action potential that will then travel down the spinal cord of the corticospinal tract via upper motor neuron, which will then synapse with a lower motor neuron at the level of the brachial plexus, specifically median and ulnar nerve, C6 through T1 root levels. The action potential will then travel along the lower motor neuron. This means it is traveling down the presynaptic terminal. The terminal depolarizes, causing opening of voltage-gated calcium channels. Calcium will then flood into the cell and trigger calmodulin, which activates synapsin, thus causing vesicles to fuse with presynaptic membrane. ACH is released into the synaptic cleft via exocytosis. ACH binds to ligand receptors on postsynaptic membrane. Binding of ACH will then cause sodium channels to open. Sodium influx will generate an action potential in the sarcolemma and inward along the T-tubules, which triggers release of calcium ions. This occurs because the voltage change is sensed by the DHP receptors. This is communicated to the ryanodine receptor, which opens calcium channels. Calcium floods into the muscle fibers and binds to troponin. This causes tropomyosin to shift and expose active binding sites on actin. When actin sites are exposed, activated myosin heads bind to them, forming a cross bridge. ATP is then hydrolyzed, and ADP and inorganic phosphate is released. Then activated myosin heads pivot, sliding the actin filaments towards the center of the sarcomere.
If Rusty can play, you should be able to play.
What do you think I was gonna like?
I got a couple of those that might work anyhow.
Ben?
Okay, here we
Here.
go.
Oh, you're still there.
Can we watch Friendly Giant now?
I know, right?
Rusty!
Just the two of us. We can make it if we try. Just the two of us. Just the two of us. Just the two of us.